Thank you for inviting me and for thinking about this topic. I would like to talk about big data, hopefully in a slightly different way than we normally discuss. This is currently my focus as part of my European funded grant. So I spend a lot of time thinking about data and what we can do with it and how we ended up where we are. So today, I'd like to tell you the story of how we ended up in the current situation, with the current opportunity and challenge we have. So unfortunately, my computer can't go any higher, so I'll go like this. We are in 2014. In this moment, it's very difficult to not notice that something is changing. And we can see claims like this one by Cisco: data is the new oil. You can see Obama, the big data president. You can see people talking about social science and all these different implications of data. You can see the European Union saying towards a data-driven economy for Europe. And you can see something extraordinary here. Personal data is the new oil of the internet and the new currency of the digital world. Now, this is the European Commissioner, Consumer Commissioner. So talking about data as the new oil is something that has become a commonplace claim, and it's not one without a consequence, of course. So if you look at this tool, which is used by investors and venture capitalists, the hype cycle, the hype chart, you can see that big data last year was just on the verge of being the most exciting topic to invest on last year. And that's something that investors look at all the time, of course. So here we are. How did we end up here, and what's happening? So this is my question. And by the way, people often live through revolutions like this in a very defensive way. So you have somebody saying, the end of theory, the data deluge makes the scientific method obsolete. Now, that's a nightmare for a physicist like me. Or you would have I also been in statistics department for many years. Look at that. Big data and the end of sampling as we know it. The end of something. And then social science. Goodbye anecdotes. And so on. So it's very often framed as the end of something. The end of something we like is coming because of data. And then there is another level, which is the level of data protection, which is very, very important for us, and should be even more important. So what's happening? Here is a little last bit of evidence that big data has become mainstream. Maybe when it ends up here, it's no longer fun. I don't know. Here is Obama.
The combination of increased digital information and powerful supercomputers offers intelligence agencies the possibility of sifting through massive amounts of bulk data to identify patterns or pursue leads that may thwart impending threats. It's a powerful tool. But the government collection and storage of such bulk data also creates a potential for abuse. And the power of new technologies means that there are fewer and fewer technical constraints on what we can do. That places a special obligation on us to ask tough questions about what we should do.
So I think this is an important point. As a scientist, in a way it's nice to see that there are fewer and fewer things that you cannot do. And of course, other questions come. And it's true. What is possible today is remarkable, and I have the impression that most people outside of this room do not know what is possible today, what is even happening today, what has been possible for the past 5 years. And that is why it's very hard to have any sort of political consumer pressure on politicians and companies. Nobody knows what's possible. So that needs to change, of course. So welcome to 2014. How did we get here? It seems like we have just woken up one morning in a data-driven society. But it isn't like this, and people working in this domain have been working towards it, and we've seen it coming, and now we are in this situation. So it's a story about artificial intelligence. That is where the breakthrough happened first. And that is how we can understand the current transition, just by looking at the field where the breakthrough happened. Artificial intelligence is today delivering on decades and decades of promises. And we can do things today with computers that were on a wish list for 50 years. And it's interesting that we can do it, but what is more interesting is how we got to do these things. And this is a story about data and shortcuts, and like every fairy tale, there is always a catch and a cost to things. So if you go back, in 1958, that's just an example. You can get many such examples. This is a conference that happened in near London, in Teddington, in 1958, and this is one of the many places where people published a shopping list of things they wanted to do with computers. They wanted to do character and pattern recognition, learning, mechanical language translation, biology, and so on, industrial planning and so on. It was a clear list, and you can find even clearer lists out there, very clearly written down 50, 55 years ago. We want computers to do this, and we call this artificial intelligence or the mechanization of thought processes. You choose. Okay, so people started to work on this. Many of these things today we can do. If you go on Google, you can translate, recognize speech, recognize handwriting on your telephone. If you speak to Siri, it will understand. If you want to translate on Google, it will kind of translate, and so on. You can find a face in an image, decide if it's smiling, make the photo in that moment. Everybody has experience of this. And in biology, we can find the genes and all these other things we do by using machines. Surely, anybody coming from that conference in 1958 would have said, well, that's what we wanted to do. This is it. This is the same list of tasks. AI has delivered. And yet there are many things that don't feel right. And what is interesting is how it happened. Because for a long time, the entire community tried and failed for a long time. This is a story of a very long period of failing. The dominant approach to these questions for decades used to be what is called logical reasoning. And people just assumed logical reasoning is the defining feature of intelligence. Mathematical reasoning, of course, they asked mathematicians what is intelligence. If they had asked somebody else, they would have gotten a different answer. But mathematicians dominated the field, and they thought mathematical proof is what intelligence is. Symbolic reasoning, based on logical approaches, searching in a space of solutions, the classical approach to proving a theorem or playing a chess match. That was the symbol of intelligent behavior. And in fact, a series of success stories very early came out about computers proving theorems and playing chess. And that was the path. So if you see, again in 1958, this classic paper, the report on the general problem-solving program by Newell and Simon, you see this clearly stated. The author is to understand the information processes that underlie human intellectual, adaptive, and creative abilities, and do it by constructing computer programs that can solve problems. The idea was clear. We build a computer that can solve a class of problems, and we're going to understand how humans do it. And intelligence is solving problems. Solving problems is searching in a space of symbols and proofs mathematically. That was unquestioned axiom. And people started to work. Intelligence, after all, was reasoning. And before you knew, after the success in theorem proving and in chess, you can find endless and endless papers trying to cast every other task into that language. Robot arm movement, robot navigation, language generation, everything was framed as proving a theorem, searching for a solution, navigating a solution space, using the same mathematics. That's the classic thing that happened in science all the time. When something works, the success stories shape everything else, and the expectations and the approaches. And so you see what is being called expert systems. Well, it turned out that machines designed in this way, starting from logical axioms and deducing their way down to consequences, proving their way to decisions, require huge amounts of background information. They are very brittle, meaning they can't resist conflicting information, noise, and real life, real world problems. And very soon it was realized this wasn't going to deliver real world tools, but the field continued producing this approach for many more decades. And this was the big problem of AI to the 70s, the 80s, and part of the 90s. Our idea of what intelligence is didn't seem to translate into anything that worked, to the point that in the 70s, when there was a pressure on the budget in the UK, people started thinking about reassessing the funding to the system. And the government appointed a clearly famous mathematician like Sir Lighthill with the task of assessing the state of the field. The Lighthill report came out, and it was terrible. It recommended major cuts. Lighthill was challenged to a television debate by the leading AI people. The BBC broadcasted this debate, which is a beautiful thing that they should do again. And you have here the three leading AI researchers of the time facing Lighthill in a public debate. And he could say the following unchallenged on television in front of them. Sorry.
The Academy of Sciences did in 1966 when it reported that enormous sums of money had been spent on the aim of language translation by computer with very little useful result, a conclusion not subsequently shaken. Failures continually occurred also in computer recognition of human speech or handwritten letters and in automatic proving of theorems in higher mathematics.
So by 1973, it was accepted that the field had not delivered. Nobody questioned it. You could have done the same thing in 1983, and people would not have questioned it. The field had not delivered. By 1988, I think you could have done the same thing again. The field wasn't delivering. The shopping list of failures was exactly the same list of failures as the 1958 document. Nothing was happening in AI. And then now, if you look at 2008, or you can pick another one, look what Peter Norvig from Google can say. Very relaxed, answering an informal question without even making a statement.
Well, I think we already are succeeding, right? Because we're able to do things every day and solve problems and recognize images and translate languages and drive cars through the desert without crashing into each other. So that all seems like success to me.
Failure and failure and failure and then success. That is what happened to AI. The list of tasks hasn't changed. We failed until the late 80s, and then something changed. And now we succeed. And what happened? Well, something shifted. Something shifted. We gave up on the idea that it's a matter of deduction from axioms, of logical reasoning. We didn't continue trying to prove that intelligent behavior is a matter of logical symbol processing, because apparently it didn't work. And people sought shortcuts, based just on finding statistical patterns in data. We weren't good enough to program explicitly something that can translate or recognize my handwriting. We don't need to. We just found a statistical way to bypass that and just make it work anyway. The idea is to show a computer a lot of examples of the intended behavior and rely on statistics and design a system that can learn to reproduce the intended behavior. Now, in that way, from the 90s, we started having success in handwriting recognition. Isabel can tell you about it. And then you would have hidden Markov models for speech. And then you would have machine translation using the same tools, by the way, as speech and hidden Markov models. A new set of success stories came out somehow from the periphery of the field from the research labs in the companies sometimes, from people who just wanted to get things done. They didn't tell us much about human intelligence, they didn't prove theorems, but they conquered a series of important tasks. And that created the cultural shift, new success stories, new things to emulate. So we went from the chess match paradigm to the statistical paradigm of finding a face by looking at statistical clues in an image, for example, where students before learned the first example in the school books, then they started learning the second example. And that was done by finding patterns in data. And so people learned that this is one possible way of getting things done in AI. And here is Norvig again.
And that's to do that through acquiring lots of data and running machine learning over it and running these algorithms. And the key here is that no matter how agile you are as coders, and I understand that you're all great, data is going to be more agile than code.
That's it, right? So simple. No need to make a big deal. It just happened. Data is better than coding in many ways. Just get a lot of data. That is what made it work. And if you are into philosophical perspectives, that is what Thomas Kuhn would call a paradigm shift. He would explain us that science is organized by paradigms, which are not just an agreement socially about what is a good question in science, but also what forms a good answer in science. And sometimes these paradigms change. And what is acceptable before is no longer acceptable, and vice versa. It happened over and over in science because it is a social business. Science is a social process. And so the way you explain and train and show examples, the way a newcomer into the field learns what should be emulated and what is a good story, changes over time. When physics succeeds, for a while everybody wants to do like physics, and then they find out they can't, but they try, and so on. So for a long time it was not acceptable to produce a statistical shortcut. Then it became acceptable. That's it. Paradigm shift. Not, this word is being abused a lot, but in the actual technical sense, this is what Thomas Kuhn means by paradigm shift. And the new success stories are based on machine learning plus big data. What does it mean? Well, this is Thomas Kuhn. Paradigms are exemplary past achievements, right? So you build a software that can learn from data and then just get a lot of data and show the software how to do it, and the software will find a way to emulate the desired behavior, and that will do what you need. So this is my paradigm shift. That's it. It's not a big story. It's a story that happens in every science all the time. Paradigms shift. People leave the field and new people move in. And AI has undergone a major paradigm shift in the 90s. And the new approach, the data-driven artificial intelligence, can achieve results by looking for statistical relations in data instead of explicitly, openly modeling things in the classical modeling way. We don't have a mathematical model of the letter A in handwriting, but we recognize it. And we don't have a mathematical model of the sound of A, but we can recognize it by training a learning system. This had the effect of putting machine learning at the very center of the enterprise. Machine learning became the center of AI, the enabling technology of AI. So here we go. Tell your students. We'll do. Gather vast amounts of data, use it as examples, train a learning algorithm to do what you need. And that's how we summarize text, translate text, recognize speech, and so on. Here we go. New AI based on machine learning that needs data. And now if you want to change a little bit Ada Lovelace statements, machines today can do things that we cannot actually understand well enough to model them explicitly. It's the exact opposite of what we said for a long time. Computers can only do what you explicitly tell them to do. Well, actually, no. machines do stuff that I don't know how to explain. And that's the point. I don't have to spend 20 years of salary for a research team of 1 million people to understand deeply how to represent a letter A in handwriting. I train a learning system, it will do it anyway. So it's a change, it's a big change. A change that we still have to absorb properly as a research community, I think. And this is the catch. AI works today. AI has a business model today, other than defense money. There is actually a real business model. But AI relies on machine learning. And machine learning needs lots and lots of data. So again, Peter Novig and others, he would have this very nice manifesto article a few years ago with very simple findings. Invariably, they say, simple models and a lot of data trump more elaborate models based on less data. They found experimentally that the difference between algorithms isn't so important as the difference between data size. That was what made the difference. Memorization, they say even, is often a good policy if you have enough data. Or simple linear classifiers based on millions of features, this is more technical for the engineers here, perform better than elaborate models that try to discover general rules. So these are just experimental findings, but they're also the start of a new way of working. So I went to take the proceedings of the big AI conference, the classic IJCAI conference, and I took abstracts and titles from 30 years apart. In 1981, everything was about knowledge and representation. In 2011, the biggest word here is learning. Learning. And that is the one logic-based symbolic AI conference. Everything else is more statistical. That was the last stronghold. They put learning at the center of what they do as well. So this is the completion of a cycle. Now we are again in a phase of normal science. Kuhn would say AI is working in this different way. But the point is that these things don't happen in isolation. When something works, it spreads. And so that idea that you don't need to understand everything, you can get things done by just training stuff on statistical, started spreading. And the next stop was biology, where people started having so much data and so many questions and such a limited understanding. And instead of spending 300 years modeling every single shape of a protein, they started training learning algorithms with data, obtaining decent results, very decent results. And that enabled an incredible acceleration in genomics, for example. And that went on, and it's still happening now in many other sciences. It turns out that often correlations found in large data sets are more useful or equally useful but cheaper than mathematical models, physical models. If you go on Amazon to buy a book, you will receive a recommendation that is decent. And in the beginning, Amazon actually had people making recommendations in the very beginning. Now they have, of course, software, and they make most of their profits from recommendations. But they don't have a mathematical or a psychological or a sociological model of a customer. They don't know why you want to buy the next book. They just know that if you buy A and B, then you will buy C. And it works. It makes a decision, it gives you a recommendation, it generates money. That's the point of Amazon, generating sales. And it works. So that's what people summarize with prediction trumps explanation. I'm just reporting now what is the current situation, then we can have. And if you go around the web looking for people talking about the big data, data-driven transition, you find a lot of claims. Some are here. Do not sample. Use the entire population. This is very unsettling to statisticians because they often saw themselves as the category of people working on sampling and probability. Do not obsess on causes. Focus on correlations. This is going to upset physicists and others. Do not seek exact results. Embrace uncertain relations. Do not start with hypotheses. Collect all the data you can. And data is more agile than modeling, and so on. So this is what you find. Of course, we are in a moment of hype, and this is found in books and articles everywhere, and students absorb it naturally. And let's assume this is good advice in AI because it works. So if you live in Google, your first reflex when they give you a new problem is, where is the data? I need more data. If you live in Facebook, if you live in any place, that's the obvious way to think for the first attempt to solve a new problem, give me the data. So let's assume it's a good advice. Is it a good idea to expect it will work, or it should work, in other domains? That's something that we should remember. Computers can do things that we cannot understand in detail. And having a computer doing something doesn't mean that we understood it. And if you know, we can talk about translation if you want to later. Just look how translation works. You understand there is no linguistics, there is no understanding of semantics, there is just statistics. And the catch, like in the fairy tales, here is the catch. These machines feed on data. That is how data gets its value. AI has a business model, computer science has a business model, there is value, and that value goes all the way to data. That's why you want data. That's why you spend for data. Look at biology, same. Social sciences, I'm working with social scientists these days, so we analyze a lot of data, and coming from newspapers, from social networks, for social media. The kind of questions you can ask today are just unthinkable 10 years ago. They would have to run a survey over 100 people and pay for it. They would have to read and collect 20 articles to analyze, or 2,000 if they can have the resources. But nobody could have analyzed discussions among 10 million citizens about a topic, but you can do it automatically on Twitter now, see what we'll say. Social sciences are in the middle of this revolution, and they struggle with it. And now people try to push it maybe everywhere, which is always going to be the case. Can we automate science? And that's the question. Some people say, yes, there are some questions in science that you can automate, and that creates a challenge. And this is often summarized as knowing what and not knowing why is often good enough. It's part of the slogans you hear. It's part of the things students will hear as they train. Knowing what and not knowing why is often good enough. And that's something that is different. You know, you can translate. Why? You can transcribe, you can predict, you can recommend a book. Why? Why is no longer asked in this approach? So if you have a bit of patience, I can let you see what Chomsky would say. Chomsky is in this interesting position that he's witnessing success in linguistics, translation, summarization, and so on, question answer, but in a way that is not using his own approach to linguistics. So he's in a unique place to look at all this. So here is Chomsky.
Well, if success is defined as getting a fair approximation to a mass of chaotic, unanalyzed data, then it's way better to do it this way than to do it the way the physicists do. You know, no thought experiments about the frictionless planes and so on and so forth. But you won't get you won't get the kind of understanding that the sciences. And these are just two different concepts of what success means, what achievement is. In this ion field, language studies, it's all over the place. Like computational cognitive science applied to language, the concept of success that's used is virtually always this. So if you get more and more data and better statistics, you can get a better approximation to some immense corpus of text, like everything in the Wall Street Journal archives. But you learn nothing about the language. A very different approach is which I think is the right approach, is to look to try to see if you can understand what the fundamental principles are that deal with the core properties. And these are just two different concepts of science. The second one is the one that has been what science has been since, say, Galileo. That's modern science. The approximating unanalyzed data kind is sort of a new approach. Not totally, there's things like that in the past, but it's basically a new approach which have been accelerated by the existence of massive memories, very rapid processing, which enables you to do things like this you couldn't have done by hand. But I think myself that it tends to lead the subject, like computational cognitive science, into a direction of maybe some practical applicability, but away from understanding.
It is always very hard to find a soundbite out of Chomsky, so that's how he is. But it is important to see when people are debating about what forms success, then you know you are in a paradigm shift. People disagree on what is the goal of the field because the new people have different goals to the old people. And also I really wanted to have Obama and Chomsky in the same presentation. Now I have them. It's fun. But I think at this point we have a clear understanding. The story is very simple. We are living in this data-driven environment. It first happened in AI. AI found the way to exploit data, to generate value, to bypass true understanding, and now this idea is spreading out. That's when the genie is out of the bottle, then you don't put it back in the bottle. So now it's out. And now the question is, what is next? For example, if you are in statistics, simple-looking, innocuous-looking question, is statistics the science of handling data or the science of understanding randomness and random samples? It used to be the same, no longer. For all of us, is science about what or is it about why? Time to talk. Do we need even a coherent narrative in science, an explanation, or are we happy with predictions? These things are becoming questions that need attention. When you go to a politician and you ask for money to do science, you normally say, we need to understand this to make decisions. But very soon, decisions can be much cheaper than understanding. They could come on their own. Like Amazon makes decisions without having a model. And the question becomes, why do we value explanation? We're going to have to explain. Why do we want to understand something, to explain something? Well, prediction is not probably the only benefit, and we must understand what is the full benefit of science. And there is more. There is just a lot happening that needs urgent philosophical attention. And if there are philosophers in the room, can you please stop talking about quantum mechanics and particles and waves? We need your help. And then there is more, because this data that feeds everything, that fuels everything, that makes everything possible, is very, very often our own personal data. Our own personal data is what has been defined as the new oil. So take some moment, please, to absorb this notion. Your own personal data is the new oil. And think about what happens to those who had the previous type of oil, which is actually oil. Well, now you have your own personal data, and that is the new oil. It's not mine, this is the European Union saying, the Consumer Commissioner saying, personal data is the new oil. So, I don't think we have an ethical or a cultural or a social framework to handle this. How can we expect politicians to make the laws to handle this if we don't have a cultural understanding of this first? The problem is that this technology is moving so fast that by the time we get our head around it, it's too late. So we are today in the position to use this approach for policing, to recommend therapies, to decide insurances. A prisoner can be facing a parole board and be told that you can't leave the prison because the algorithm said so. It's possible today. You can't borrow the money, you can't insure your car, you could be reoffending, you could be offending. These things are becoming possible, and we don't know how to think about them. And believe me, it is not good enough to repeat the same old tried thing. If you have nothing to hide, you have nothing to fear. It is not good enough. It is not clever. It is just hurting everybody else. And there is a lot happening. And in fact, there has been an interesting report recently. So, by the way, as businesses find a way to collect your personal data to monetize quickly, They do what they do. They make money. Governments, of course, have access to this data, and they do what they do. Policing or law enforcement, we hope, or maybe something else, we don't know. The truth is we don't know, we can't know. And consumers are happily ignorant about both activities. They just don't know what's happening. And then they don't mind, which is even worse. So this year, the White House commissioned various reports, and they were released, and one interesting one says, these capabilities, most of which are not visible or available to the average consumer, also create an asymmetry of power between those who hold the data and those who intentionally or inadvertently supply it. The asymmetry of power between the data holders and the rest of us. That is only growing, and that is going to change a lot, and a lot. Small thing, you know, sometimes small things change a lot of things. And then unintended consequences that the government can demand access to this data. So of all the things that happened in the last 15 years that made us surrender more and more data, you know, you have in Europe the financial crisis, in America the security emergencies, but then you have actually a lot of us just wanting the convenience of being like me, doing email from the phone. So simple, it's convenient. And we surrender so much of our personal information just for convenience, but because we don't normally know what's the cost of that. So it is an important step. I wonder if there is something here. Let me see.
The combination of increased digital information and powerful supercomputers offers intelligence agencies the possibility of sifting through massive amounts of bulk data to identify patterns or pursue leads that may thwart impending threats. It's a powerful tool. But the government collection and storage of such bulk data also creates a potential for abuse. And the power of new technologies means that there are fewer and fewer technical constraints on what we can do. That places a special obligation on us to ask tough questions about what we should do.
Okay, so I think it's clear what happened, and the interesting part is we are the ones who made it happen, not only as scientists but also as citizens. And the truth is we don't know where this is going to go. Schools started data-driven schooling, maintaining databases, data sets about children. I know some schools were in the UK, they're using fingerprint recognition for many identification purposes. Everybody's using fingerprints on the telephone anyway. We are happily sharing our personal data in every possible way. And then there is marketing, and then there is advertising, there is surveillance, there is policing. You see, data is not just the camera filming the street. That is something. And then there is complete coverage of internet traffic, completely monitored, emails, clicks, searches on Google for every single person. There are companies in the US who are boasting of having achieved 100% coverage of the population there for marketing purposes, meaning in terms of having data about every single individual. And maybe it's impossible and maybe not intelligent to just stop things. Can't. But the solution will not be a technical one. We're not going to invent a new tool that makes everything good. We need to evolve culturally. And we need to enlist the help of other types of people. Engineers are not maybe the right people to understand and explain what's coming, what's possible. And you know, some things are today legally possible and technically possible and clearly not desirable. What is going to stop them from becoming possible? As soon as somebody can find a way to make money, they will do it. So it is on us, the job of understanding and explaining quick. And there is a model. The model of the environmental movement, for example. Because at some point in the past, people just assumed the world will be more and more DDT and more pollution and more industrialization. That was the image we had of the future. And then at some point, somebody was able to write a good book and tell people that this could be not entirely desirable. And slowly, it created an awareness. Consumers acted on products. voters acted on politicians. Politicians spotted the opportunity to get some support by embracing some different values. And now, actually, things are cleaner than they used to be 40 years ago. So now, we are led to believe that the world is going to be less and less privacy, less and less control on our personal data. But it doesn't need to be like this. So long as we can understand and vote, I think politicians and companies will find a business and a political opportunity in respecting more and more personal data, and it will be up to us. But before that happens, we have to explain things. And so we are in this situation. In the UK, people sell these kind of things, shed a lot of data. It's incredible if you are a data miner like us. After many years of work, suddenly you find your own data-driven work on television and everywhere. But that's the world we live in today. It's a story about a shortcut and a revolution and a catch. The shortcut was that machines became capable of generating value without the need of being programmed directly. It was a major change. We did it by machine learning. Beautiful achievement technically for us. The catch is all that feeds on data, often our own personal data. And that's the little spell, like in the fairy tales. And so it is time for us to seriously think. That's all. Thank you very much.
Just got one question for you regarding artificial network and artificial neural network. When you talk about the network, from your point of view, are they actually black box? Do you consider them as a black box where you put the data through them and then process them? Or do you think they are different than that?
Well, I didn't talk about neural networks.
But it's type of artificial intelligence, actually, system.
Yes, so I would count neural networks in the statistical domain of something that works without the need for us to understand its inside. Yeah.
Right. Okay. But, I worked through it actually for quite a long time, and from my point of view, it's not a black box where you put the data and actually process them. There is a learning process that associated with that, and this is where actually we learn, and the data will be actually processed and learned, and then actually the system will be more intelligent, like any type of artificial intelligence. What's your point of view from that?
So when your neural network tells you you can't have a mortgage, and you ask why, can the network answer?
No, unless you train it, but you need to train it.
The network, as far as I know, based on what I know, the network doesn't know why. The network can make a very good prediction about the risk of defaulting on the mortgage.
It depends on what you're training it with, isn't it?
Okay, so perhaps we will take this offline. Another question? Yeah, you bet.
So, what is the research program for AI now?
Well, it's a good question because it's a very good question. Because I've been thinking, I don't have an answer, first of all. So if you want, I can stop here. But just as an extra comment after I don't know, there is this other comment. We often end up dreaming the kind of things we can do. During the days when logic approaches were mainstream, people dreamt of all possible ways they can use theorem proving and deduction. They found whatever niche was available to do deduction. They found some that were not treatable, and at first they said, that is not really AI, that is just translation, that is just speech recognition, that is just face detection. There was a long list of things that were just not AI, and they focused, but AI, however, can play chess and checkers and Go, and maybe also some tic-tac-toe. So they were just deciding what AI is based on what they could do. Now it is no different. We have this new set of tools, and whatever we can do, we call it AI, and we try to force everything into this framework, and be ready and be prepared, embrace yourself for data fundamentalism to come. Everything will be data very soon. Everything will be based on statistics, and many things cannot be done in that way. It's hard now to focus on those, but we shouldn't stop dreaming just because we can't force something into a data-driven statistical framework. There is more. But if you ask me, what will be the next thing we do after we change paradigm again? Well, if I knew, it would be already happening. But there are lots of things to do with humans, conversations and so on, that are just right now not possible to machines, and at some point they need to become possible, and so there is plenty.
Okay. Actually, I had one question. So I think that the point you make about the fact that we should be more careful about our data is something which is crucial, and still have some doubts about the fact that it might be practical. In the sense that there is the legal...
There is
the legal aspects.
Mm-hmm.
Okay. There is the technical aspects. And there is also the fact that if you have friends who give up their data, that it means that a sufficiently sophisticated inference engine will know a lot of things about you. So to some extent, I'm just wondering if the privacy is just une ligne Maginot. So you might remember. You might remember that this was the thing that France was building, you know, of course, yes. So I was wondering whether you would like to comment upon this.
Well, I think that values may change over time.
Right.
But we need to understand the data, in my opinion, in terms of human rights, not in terms of intellectual property protection, personally. And it is possible to make claims like personal data belongs to the person. It doesn't matter who has collected it and who is storing it. It should be possible for a person to do whatever they want with it, including deleting it. That is not today possible. We do not have a right like this. It is conceivable that we demand the right to examine, sell, and destroy any data about us. That's something we should discuss. But so far, it hasn't been discussed. It is true what you say, that people like me, by surrendering their data, give information about me. But at least it will not be personal information. Personal information in this moment is information directly linked to a person. It can be incriminating, it can have a lot of consequences, whereas the information they collect from my neighbors can have a marketing value, very accurately actually, to recommend goods to me, but it will have less of a legal value. It will be very hard to imagine, although you never know, that I get denied a mortgage because my neighbors defaulted, although you never know. But certainly we need to think about rights, human rights, values, and once there is a general understanding of what we want, then we can put pressure and request things. Right now, we don't know what we want.
That's true, I agree. Okay, so...
Isabel.
Oh, yes, Isabel.
So thank you very much, Nello, first for pointing out the importance of data. That's something that we've experienced for so many years and now is recognized, so I think it's wonderful. I would like to come back, though, on one point you made about correlation is good enough, we don't need causality. And put that also in perspective with respect to the idea that we can recommend and do the what without knowing the why. Now, would you do that for medicines? Would you have a recommender where you would recommend to people, take this and you'll be better off because the system learned it from examples?
Right. I have two things. Thank you very much, Isabel. And a lot of the things you saw on the screen, Isabel knows very well for a long time, and before people wanted to do them, it's also your fault, you know this. But I have to say two things, so please bear with me. About one is what I put on the screen is not my personal opinion, it is what is the current zeitgeist. Correlation is useful more than causation. Knowing what and not knowing why is often good enough. Yes, there are domains in which we are not prepared to accept it. But here are the two comments. One is that I had somebody telling me the following claim. When the Google car becomes safer than a human driver, it may become unethical for you to drive. And that's an interesting thought to entertain for a moment, because prediction in that case, the capability to be efficient, may put pressure on us. That could happen for recommendations, even for diagnosis. If the machine is better at diagnosis than a human, should we expect humans to do it? It's a matter of performance. And we don't have a tool for that, conceptually, philosophically, to answer that question. Do you still want a human doctor? Or are you going to be happy with the machine because the machine is better on average? I don't have an answer for that. There was another point I was trying to make. Yes, about explanations. Now, besides that point, that we may be under pressure to accept things because they work better. What is an explanation? You can say machines can also be built to learn causal explanations. But the truth is, we are just moving the problem. It's interesting, again, if philosophers were interested, to discuss about what an explanation is. Because an explanation or a scientific theory is not just about building a predictive model, although it must be predictive in science. It also needs to somehow fit within the bigger picture of the bigger other theories and other beliefs and other systems we have. In the time of Galileo, it was unthinkable to have a cosmology that wouldn't be geocentric. It was clashing with other beliefs we had. Today, it is unthinkable to show up in a cosmology conference and make a geocentric system. They will laugh at you. But in both cases, it is not a matter of predictive power. You can build models in both ways. It is a matter of fitting the bigger system of beliefs. So when you ask a machine to generate an explanation for a decision or for something, whether the explanation is acceptable or not depends on a lot of cultural things. And that is one reason why it's very hard for machines to make an explanation that fits everything else. That could be the key. That could be why we needed them desperately to build a coherent story and give us this emotional impression of understanding something, which is often less deep than we would like. But if you think machines can explain things, that would be an interesting technical challenge. But whether that is the line of defense, I don't think so. Very soon prediction may become very good in some domains, and then we may have this paradoxical situation, which happens to humans already, that decisions are made in one way and explanations are generated later in a different way. Neuroscientists know this very well. You make a decision, you act. Half a second later, your brain makes a story about why you acted. They may not be the same thing.